So let's start with a quick introduction. As you may know, WhatsApp is one of the most widely used messaging app on our mobile phones. It allows us to exchange messages such as textual messages, images, documents, videos, audios, and so on. And those can be really important data and information during forensics analysis. Traditional forensics analysis can take a lot of time to analyze all those data, especially if we talk about hundreds of thousands of messages. Thanks to the use of the AI tools, the analysis can be faster, and we can extract also very important information for those images and files. Let's have a look to our system architecture. It may look difficult, but we will deep dive all those steps, step by step, and you will find that it's so easy. First of all, we need the message database and the media folder. Those files can be extracted in different ways depending on the type of operating system we are working on. For example, for Apple iOS devices, it's needed a simple unencrypted backup taken with Apple iTunes. After that, we put all those data in our tool, and we need to translate, and all images and audio needs to be converted into textual form to be analyzed. So text is already text. And for images and audio, we decided to implement some algorithms to, how to say that? To convert images into textual form. We decided to do both open source, total open source, and also we decided to make the user choice if he wants to use Microsoft Azure services, such as computer vision or speech-to-text service. We will see that later. In our configuration page, we have a box right here when the user can select if he wants to use Azure services and which Azure services he wants to use. For example, image captioning and OCR or speech-to-text, OpenAI GPT if you want to use also OpenAI GPT as LLM. Image captioning, let's start from here. Image captioning allows us to obtain a description of about what is contained inside the image. For example, in this image, we have a small kitten, and if we paste this image in our image captioning system, we obtain the description reported on the right. This can be achieved by using Azure's computer vision services or the Salesforce Lavis open source tool. Image OCR allows us to extract text from the images. So in this case, it works by analyzing the image and converting all the text and numbers into a researchable and editable text. Then those text can be stored and researched in our tool. Then we have the speech-to-text analyzer that takes as input the message, the audio message, and converts it into a textual file. In our case, we discovered that WhatsApp stores messages, audio messages in .opus file. So we need to add a new step, which is the conversion using FFmpeg to take the opus file into a WAV file, which is compatible with Azure services. Now that all our messages, audio, and images are in a textual form, we can put them and pass them to the analyzers, and this is where AI comes to play.
Okay, spooky AI. So, the first analyzer is a Presidio. It's a Python-based services that extract PII, that is personal identifiable information from the text. Okay, this is fully open source, and you can host locally, so no data information were exchanged to the cloud providers, and is easily extendable using also YAMLs file. In this example, we are creating a recognizer that recognizes Bitcoin addresses and extract it automatically from the text. And also, we can expand it using LLP engines or programmatically using Python. Another tool we use is DPAS. Is a specific tool, Dockerized application, to extract passwords from a document. The project is open source, so we forked the repository and made another customization to the project to make a REST API. This service is made through REST API, so we can use HTTP calls to use these services. We also use LLMs. First, we use the big code is ANR, named entity recognition, training on several datasets containing PII, and able to extract 6 classes: names, emails, keys, password, etc. We also use ChatGPT. First, to use ChatGPT as classifier, we need to create an assistant, and this is the assistant prompt. Hi, you're an agent to extract personal data from text. This is the entities you need to extract: credit card, password, and I expect the output to be a JSON. For each entities, you need to extract the entities and make it available in JSON format. So this is the example, and I expect this as output. So there are a constraint in LLM's ChatGPT assistant that specify that we want the response as JSON. And also, we set the temperature to the minimum to avoid LLM's hallucinations. So the next is a tool using Azure AI Foundry. So Azure, Microsoft. This tool is a part of the Azure AI Suite. It's an app that extracts a whole range of PI from text, and is integrated via a dedicated library. But unlike Presidio, it's not custom. You can not extend it with custom recognizer, and this is fully online. So personal data we exchanged with the cloud provider. This is the system architecture.
All the information extracted from our analyzers are now stored into a defined object, a structured object that can with particular attention to PIIs, so personal informations, and also to the password extracted by using systems like DPAS. Then all those information are stored inside a database. In our case, we decided to use a PostgreSQL database, but each database can be used. We do not need to create table at the beginning because we use the SQL Alchemy, which creates automatically all the tables at the start of our tool. Here we show you a use case. So after selecting the database on which we want to do the analysis, we select the AI feature. And here we have a mask in which we can put the start date time of our analysis and the end time, so we can check only the messages in a specific time range. Then we select the messages we want to analyze, received or sent, the message type we want to analyze, the phone number, groups, if we want to include also groups, and then the list of all the analyzers that we want to use. Then we are automatically redirected to another page which shows us the status of the analysis. And at the end of the process, a new button will appear on the right to show the results of this analysis.
OK. Here we are the first use case. Here there is a chat between a client and their accountant. Is analyzed by a investigator. And we see that there is a screenshot of invoice exchanged. The OCR extracted all these informations. Oh, sorry. OK, the one. OK. Yeah. Explaining. Okay, maybe now. Oh, okay. This is the second.
So here we can see all the analysis that we performed during our tests. And we can see also a quick recap of the status of the analysis, including also a flag to tell us if we selected sent and received messages, so which kind of messages we included, the contacts included into this analysis, and the groups we included. We have also the process ID, start date, and end date for each analysis. I don't know why the video is not starting. Okay.
Okay. So this is the second use case. We here see how a crypto investing strategy, this is the name of the group, and a scam is taking place. The first is like the speech-to-text technology, that's converse audio.
Oh, thank you. I'm interested. But how do you transfer funds? I have an account on Coinbase, but the fees are sky high.
This is original message audio. Then we extract these informations. Also passwords. Later we can talk about this. This is the second audio.
Okay. How do I transfer the fund? Is it safe?
So here they are extracted the Bitcoin address from different analyzers. Okay, this is the password, original. So here we see an example of a scam taking user information using a WhatsApp group. The next, okay, is the last use case, and involved two friends chatting about a trip. Okay, here the captioning. This is the image. This is my real cat, Lucy. She's beautiful. Better than a general image. And the AI recognized this, a cat in a bucket. That is not a lot of information, but is only an example. So later, from the screenshot of the phone, we can extract a lot of information, only using OCR technology. The first, a screenshot of a phone, is the caption, and later all the information extracted. Date, time, name, my name, his name, is the focus on the screenshot.
This is a flight reservation of our last trip in Bologna.
Time of arrival, cities, date, time, etc. So we see also the hotel in Bologna, so we can fast location. We can search for location. Okay, this information. We see that deep pass model that we extend has a lot of false positives. That is a problem, but the fact that if I insert a password, okay, and I have at about 90% of false positive, that means 10% of true positive. But it's like one password on 10 records. So it's, for us, it's an achievement because it's good. I don't have to read all the messages, but every 10 messages, I can find a real password. So,
thanks for watching.